This conference will now be recorded.
Okay, we are 5 minutes into the session, so let's start. Okay, if we are going to talk about AWS cloud computing, um, before we get to the actual AWS courses and contents, I just wanted to take you all through some foundational cloud computing concepts, and then we'll get into the actual AWS, right? So, what exactly is a cloud computing? Okay. So, is there anyone who's from non-IT who doesn't understand on the basic computer science basics or anything? Anyone from non-IT? Then accordingly,
Yes,
I'll be able to take it.
yes, sir. I'm from non-IT background.
Yeah, Hamza, can you just give some brief around what do you know about the software and everything so far?
Not much. I was trying actually to get into testing. I was just going
Hmm.
through manual testing, but then I just thought about this AWS. And when I checked with, so they said it's a non-IT, like it's for non-IT people. You can try. So I'm just trying to
Okay.
more clear.
It's basically a platform anyone can try, and this is that the foundational platform that everybody will be learning nowadays. Okay, irrespective of which role you are in. Okay, this is something which is foundational to everyone. Okay, yeah. Anyone else? Okay, that's fine. So, Amsa, you can stop me in case if you're not able to understand or catch up with. Okay, I'll slow down. Okay,
Yeah. Okay. Thank
okay, good. So, first of all, we need to understand, okay, how the software will be developed. Okay, then we'll be able to get into what's the platform, middleware, and actually the application layer. Okay, so let me show some diagram. Let me share my screen. Okay, and show something what is relevant to this topic. Hope you all can see my screen. Can anyone confirm?
Sorry, I can't see your screen.
you. No, I'm not able to
Okay,
see anything. Yeah.
okay. Let me check. I think it's still coming up. How about now?
Yes, that's
Okay.
Sorry, sorry, we can't see. Yeah, no, it's fine. Good, thank you.
That's good. Now, is there
Yeah,
anyone
yeah, it's
still who can't see the screen? Okay. So basically, okay, you will get this information on just the Wikipedia as a then just say cloud computing on the Wikipedia. You will be able to get to this page. I'll show you. Okay, so let's say you are developing any application. Okay, there are three fundamental things that's always required to basically you to run the application. Okay, of course, developing the application is through the entire SDLC, but in order to run the application, there are three fundamental things. One is, of course, your application, what you have developed. Second thing is your platform. Okay, the platform in the sense what's your runtime, where is your database, okay, where are you going to store your data or the objects, okay, and what type of middleware you are using. Majority of these things will be on the middleware side actually, and the foundational thing is basically your compute, your backend storage, and your network. Okay, so if you are a computer science student, there is something called a networking concept in your academics, which explains the seven layers of entire the software, right? But this is actually simplified into just three simple layers: application, platform, and infrastructure. Okay, so one thing before getting into the cloud computing we need to understand is that what is the difference between the platform and an infrastructure. Infrastructure is a standard thing which is not majority of the time not going to change in any organization, which is your hardware, which is your backend, like the block storage, like your tapes or your uh, basically what you call it as, okay, the central storage, and your networking, basically all your connectivity between the multiple systems and everything, right? But whereas the middleware is the key part here. Okay, so how are you going to use your database? How are you going to use your, like if you want to do the communication between multiple apps, usually you'll be using some MQ kind of a thing. And like let's say you want to run a Java program, you definitely need a Java virtual machine. That's also part of the platform. Okay, and your authentication and authorization. Okay, and wherever you're producing some objects, you're going to store that in the platform. Okay, that's the key component actually. Okay, and based on what type of application, let's say you have a financial application, you are going to develop that application logic and everything at the application layer, which is going to interact with your platform or will be run on the platform. Okay, that will be leveraging the infrastructure compute, okay, or the overall networking, everything, to run this or communicate, transfer the data and everything. Okay, so this is in general a cloud computing application will be, or normal any application. Okay, So these are the various things, and you can use these applications in any form or shape. Okay, all this stuff. So now, what do we have actually in the cloud concepts as a concept, right? So you have infrastructure as a service, you have platform as a service. So if you look at all those areas, so you have an infrastructure as a service, you have platform as a service, you have software as a service, and you have backends mobile as a service, and also you have recently there's something called a function as a service, which is called serverless computing. Okay, you might have heard about AWS Lambda and everything. Okay, so that's one. So what are the services any cloud models or a cloud offering can give is all these things. Don't get confused. Don't worry if you don't understand this terminology. We'll simplify how you can understand this terminology. Right. Next thing is based on what type of infrastructure you have. Let's say you are installing all the cloud computing within your own premises versus you are sharing with other companies versus you have a standalone public cloud offering, or you are just on the public cloud without any clue where this content is, everything that will be called private, public, and hybrid models. Okay, so these are the deployment models where your content is stored. Based on that, it is called as public, private, or hybrid. Okay, we'll get there also. Okay. Another thing is we need to look at what is the architecture, what kind of things that you are storing in the cloud. Okay, there are some that will be stored in on-prem, some will be on the cloud, and how are you going to take care of the security of this cloud? Usually, the moment you say public cloud, it is out of your network, out of your company's infrastructure. So then, how are you going to take care of the security and privacy of the data and the applications that you're going to store? Okay, what are the advantages and disadvantages of cloud? Okay, what are the latest and greatest things that's going to happen in near future? Okay, all these things we'll talk about. Okay, so in order to simply understand, okay, what are these various service models and everything. Okay, so we can actually get onto a simple analogy called pizza as a service. Okay, so there is actually a concept called pizza as a service. Let me show you all what that mean. One second, let me move this things onto the side. Okay, so this concept of pizza as a service is just a simple analogy that um, one of these enthusiasts have developed. Okay, but it's actually going to be a very interesting thing. Okay, so let me show this diagram. Okay, or a image. Okay, so first let's understand. Okay, the foundational things which are infrastructure as a service, platform as a service, and software as a service. Okay, these are the foundational things that we need to understand first, right? This is what. Okay, so the way it works, let's say you want to eat pizza. Okay, there is one way that, like, each of these are different ways of how you can eat pizza, right? So let's assume that you wanted to eat a homemade pizza. Then all the things that you need to really prepare and eat a pizza is basically right from the ingredients. You are preparing cheese, the toppings, the base, dough, everything, okay, at home. And also the, of course, your own kitchen you're going to prepare. Okay, and you're going to use your either electricity or gas, and you're going to use your own beverages, and you're going to sit in your own dining table and then eat it. So everything is at home, so nothing outside of the home you're actually getting it from. So everything is prepared at home and you're baking the pizza at home. That is called on-prem. So if you have everything prepared, stored, deployed, everything, just like an application. You're developing the application completely in home. You are deploying that application on your own infrastructure, You're going to maintain and run that application on your own infrastructure. Okay, that's called on-prem. Okay, so coming to the next section. Okay, so let's say you have brought the ingredients basically. Okay, so for to prepare a pizza, you need the basic ingredients, which is of course dough, the base, the some tomato base, and all the toppings and cheese. You bought it from a supermarket, and you prepared your own pizza in your own oven. You had your own dining table with your soda and everything, and then you're having it. So here you still prepared the pizza, but there are some fundamental things that you brought it from outside, which is actually a supermarket. So this is called an infrastructure as a service. Okay. So that means you did not prepare the ingredients on your own. You got these things. So similarly, if you say infrastructure as a service, okay. So what do you mean by earlier diagram, whatever you're looking at, okay. So if you can look at this infrastructure as a service, your backend compute hardware and network is not actually on your premises, but this is hosted by somebody else. Okay, so only the hosting actually. So that means only that infrastructure they are providing, no nothing else actually, no other services. So that's called the foundational thing is called infrastructure. So if you're using only that, okay, let's say in the AWS itself, if you are using only their infrastructure. That means you are just taking some space to put your applications, but all your middleware is taken care by yourself, your licensing is taken care by yourself, and all other things which is your application needed. Okay, apart from that basic infrastructure is taken care by your own company, then that's a pure infrastructure as a service. Okay, so that's another analogy. Let's go to the next level. Okay, so okay, you want to eat a pizza. Okay, another simple thing is you can just order it from outside, either Domino's or something. Okay, which is coming to you ready made, but you're going to eat in your place. Okay, with your own dining table and your own soda. So this is actually going to reduce lot of the preparation time and all other spends that you have actually. So be it the fire, oven, or electricity and all this stuff, right? You don't need to prepare it. Okay, so this one you actually moved up one more layer, which is going to be offered by the third party, right? So here you're the middle layer part, actually your actual platform. So assume that kitchen is your platform. Okay, your platform is also outsourced. That means you are not using your own platform, you're using a third party platform where they're going to prepare the pizza and then give it to you. Okay, that's called platform as a service. So when you're leveraging the platform from a third party, that's called a platform as a service, because the third party, be it AWS or any other like Google Cloud or any other, they are providing that entire platform as a service. Of course, that includes infrastructure as a service, okay, as a default thing. Okay, so when you go to the platform as a service, obviously this second part, okay, this part, the platform part, that means your Java virtual machine, your databases, your authentication authorization things, and your MQQs, all these things will be given as a service to you by that particular service provider. Okay, it can be Amazon, it can be Google, Microsoft, anyone. Okay, so that's called a platform as a service. And the next step is, of course, you can drive into a pizza shop. Okay, have the pizza directly then and there. Okay, then the advantage over there is, of course, you're not even using your dining table or soda. Okay, that means you don't have to prepare your app also. Okay, so the major difference here is you don't need to develop your app. So infrastructure as a service, you don't need to take care of your infrastructure, it will be provided as a service to you. Platform as a service, even the next layer, which is the platform, the core platform where you're going to deploy your applications, is also provided as a service. Now, software as a service is nothing but you're developing the software and then giving it as a service. So you as a client or a customer don't need to develop your own software also. Okay. So this is called SaaS based software, right? Like there will be ready-made software. You'll be using that as a service. Okay, you will be using based on your need, and then you will pay for it. Actually, as simple. So let's say you're dining it out. Okay, that means you're going to restaurant and then you're actually going to uh, eat it and then come out. Okay, So that's called software as a service. So in that view, this entire application layer is also not developed by your own company. Okay. But there are predefined applications or pre-developed applications where you can use. Let's say you want to do a financial calculator. Our best example, for example, is that okay, your Microsoft 360 or your Excel. Okay. Excel as an application is not developed by you, okay, but it is developed by Microsoft, okay, but you are going to use it, that's it, right? But if you are using the Microsoft Excel or all the Microsoft Office in the traditional way, like where you are going to download the entire software, you're going to install it on your local laptop or desktop, and then you will start using it, that is still on-prem, okay, because that application is lying on your own infrastructure, on your own platform. Whereas if you are already using Office 360 in your offices, or if you heard about it, that is completely a cloud-based solution. So this Office 360 is not installed or hosted on your company, but it is hosted on Microsoft's infrastructure. So, but you're using same Microsoft Excel, okay, in your company, and actually it will have better advantages because you can use that in any device, okay. You can use it from iPads or you can use it from your laptops or anything because it's all public cloud. It's basically it's on the cloud, okay. So that is called software as a service. So same Excel, if it is installed, it's called on-prem, but where it is in the cloud and you're using it, okay, it's called your software as a service, okay. So that's the fundamental difference between infrastructure as a service, platform as a service, and software as a service, okay. Any questions before I get into one more element which is called serverless or a function as a service? All
You
right.
repeat once SAS pass
Yeah, sure.
just in a
So
single word. It's enough. Yeah.
yeah, so in a single word, like I would say, refer to this diagram, I can give you that link, okay. In any application you have three basic elements. Of course there are different seven layers when you look at the security and all, but fundamental things is you are developing your application, you need a platform to run your application. That means you need relevant database or the middleware where you're going to deploy your application. Let's say simple example, right? So let's say you developed a Java application, okay. That Java application is basically a web application where you need to deploy that entire jar file or war file, okay, once that is developed onto a Tomcat, which is called your middleware or nothing but platform, and that connects to a database, of course. So your application is actually in your application layer, your Tomcat and then database is actually in your platform layer, whereas your hardware, where like let's say your company infrastructure or your hardware where you're deploying that entire thing is actually your infrastructure, okay. So that entire thing, if you say like these are the three layers, right, like everybody understands what an application consists of. You have an application, you have a platform, and you have an infrastructure, and you outsource this infrastructure. That means you are deploying this particular application on a cloud. That means you're not on your company, somebody else is offering that as a service, okay. So rather than actually creating your own servers, why don't you use my server, I'll charge you less, kind of a thing, okay. Then if you use that infrastructure, okay, of a third party, that is called infrastructure as a service. But you are using your own Tomcat licensing, you are using your own database licenses, okay. You are going to install your own Tomcat, install your own license. Only the infrastructure is provided by them, only the hardware is provided by them. That is called infrastructure as a service. If you go one more step further, which is you are getting a service provided by the company, that okay, I will take care of your Tomcat installation, I'll take care of your database installation, licensing, and everything. You just deploy your application, the rest will be taken care by me. That is called platform as a service. If you go one more step further, say you don't need to develop your application also, I have this developed application ready made, you just use it and pay for my service, that's it. That's called software as a service, actually, SaaS. Okay, so that's the fundamental difference between these three. Is that good?
Here AWS is the platform as a service,
Yeah,
correct?
AWS can do all three. AWS can do all three actually. Okay. So
Okay,
AWS as a service provider, it can do only infrastructure, it can do platform, it can do SaaS also.
okay, okay,
Okay,
done.
because it has developed those so many things. Initially, you're right. When it initially started, it's only infrastructure, and then moved to platform, and then now, and it has forwarded one more thing also. Like now, that's what we're going to talk about, which is called function as a service or
Okay,
serverless.
okay. What is that? Functional and service serverless.
Function function as a service, or it's also called as serverless.
Okay,
Okay, this is the one actually. Okay, serverless computing or a function as a service. So you can just for this beginners, you can use this message. I just kept the link in the chat. Okay, let's get into the function as a service, right? So this is the next expanded version, okay, of the same pizza as a service model, okay, with couple of additional elements, okay. Um, One is okay, function as a service as we talked about, okay. So this has taken like to the next level, okay, where your platform as a service or a software as a service is basically software as a service is basically of course at the end actually, but in between, okay, you have your additional elements, which is one is container as a service and actually your function as a service, okay. So let's talk about function as a service first. So different analogy here. Okay, of course you are going to get your pizza and your soda or beer. Okay, and then you are going to have that basically with your friends and with your own friends and conversation within the restaurant. Actually, it's not a takeaway; it's still in the restaurant. Okay, but you are going to call your friends and you're going to have the conversation. But what if you attend a function, okay, which is called by some of your friends or relatives, okay, where the friends are automatically there, everyone is there. It's only the conversation that you're going to own. Okay. So if you look at this, the function is basically a simple thing where you will not be able to basically identify where your application is hosted. Okay. So usually an application consists of multiple functions, right? Okay, if you can split that actually that particular application into multiple small functions, okay, or multiple small features, okay, and if each feature can independently run using your infrastructure, okay, and at the same time they can come together, okay, and then talk to each other, okay, so that's called function as a service. The concept of friends here is actually making that possible. So if you are all alone going to a restaurant eating it, okay, then it's still a software as a service, okay. Whereas let's say you called some friends, okay, and eating together in the restaurant again, okay, that's called function as a service because each individual, each of your friend can order whatever they want, okay, and but still you can have the conversation. So you're going to go with a group of friends and then actually have it, okay. So that's what is called function as a service, okay. You're splitting the entire application into small functions and hosting that function separately than as one common application. So the advantage of that is that, okay, let's say out of four friends, one friend had an urgent call and then he or she want to move out. Absolutely fine. Your function is not going to disturb. Your overall thing of getting together and eating with friends is not going to be disturbed. That's okay. Okay. So same thing in an application when you deploy, if you want to change one minute thing, then you need to undeploy your entire application, fix it, and redeploy. That means it's going to impact everyone or every function in your application if you deploy application as a service or if you do an application as a service or a software as a service. Whereas if you fine tune that, create small functions or small subsections of that application, you can independently, okay, run that application. So if you have heard about this concept microservices, microservice architecture is actually depending on this one. So the microservice is actually like an entire microservice installation and then deployment is possible because of this. Okay, so you can get into the function level. So one application you're going to split at a function level, and then you can independently run, deploy, undeploy, run that particular function, which is a good thing. That's one area. And another similar thing nowadays getting very famous is container as a service. Okay, so first of all, we need to understand what is a container. Okay, does anyone have an idea or never heard about containers? Anyone heard about Docker, Kubernetes? Okay, so you might have just heard or maybe looked at when you're looking at the cloud learning something called Docker, Kubernetes, or containers, right? Okay. Uh, One thing we need to understand is why do we need a container at all? Okay. One major problem when you're handling an application, when you're trying to deploy an application, is that too much dependency on your, again, same infrastructure, platform, and your application layer. And when something changes in this particular application platform, it is eventually going to impact your application. So let's say you have a solid application that you have developed. In your development environment, it is working fine. In your UAT environment, it got tested very well. But eventually, when you move that application to production live, it started failing. Nothing changed in your application, either code, okay, or anything, because it's the same code that you have moved from one environment to another environment. But eventually, it is failing in the production environment. The reason for that is your platform and your configuration. The platform you have tested, let's say you have tested in Tomcat 7, but whereas your production server has a Tomcat 10, or you have one database version in your testing environment, production has a different database version. This is all called config basically. Okay, so your application as a code, it is there is no change, but the underlying platform and the infrastructure configuration is different for each environment. That is when your application is going to fail. So, in order to avoid this failure scenario, they came up with a concept called containers. So, the container, what it will do is it is going to pack your platform infrastructure config along with your application. So, when you are moving this application from one environment to another environment, you are not only moving the code, but you are moving along with the config. Okay, all the basically the platform related configuration and the infrastructure related configuration, all that will be moved together. So the advantage there is this is like a black box, basically black box kind of thing. Like usually, you know the shipping concept, right? So the container will be logged. Okay, once everything is inside, it will be logged and sealed. It will not be opened till it reaches to the destination, and no one can figure out what is there inside actually. Okay, so even if it is going to move from multiple shipyards or through various locations, various channels, but eventually this container is moving as one piece. So in that container, you can have the application, you can have the platform and infrastructure and everything. So that is the concept. That's why the Docker is actually the named after the dockyard. Okay, for that. So basically, you are combining your config, platform and infrastructure config along with your application. So that will reduce the failures because of config. Okay, if there is a code issue, of course, there no one can help. You need to fix the code. Okay, so that container as a service is also okay has been developed recently. Docker is basically again a platform for the containers. Kubernetes is basically something called an orchestrator, okay, where you can work with multiple such platforms or multiple such containers, load balance all of them, okay, and customize all of them, okay. That's what is called Kubernetes. Okay, and Amazon AWS also has similar services. Let's say instead of you have EKS, elastic Kubernetes services, and in Amazon also you have okay ECS. So there are various services that Amazon also provide, which is going to help with the Kubernetes, Docker, and all this stuff. We'll get there actually when we talk about it. Okay, so this is the additional things that you can consider, but the foundational is only these three, okay, which is your infrastructure as a service, platform as a service, okay, and software as a service. Okay, these are the foundational things. Okay, and we talked about the deployment models, right? As I already mentioned, if everything is in your premises, that's called on-prem. But even on your premises, let's say you talk to AWS or Google or Amazon, and then tell them, okay, I'm good going to cloud, but I don't have confidence on installing my applications on a public domain. Why can't you create a cloud for me and run that cloud within my own premises? It's again a cloud flavor. Okay, that means each application will not have a separate server or a VMware machine or anything. It will all be in the cloud. Okay, there will not be any specific application related infrastructure. Every application can use that particular cloud, which is installed on your own premises, which is called private cloud. So if the cloud offering, the cloud infrastructure is within your own data centers, okay, within like every large companies usually will have maintain their own data centers. If the cloud is within their own data centers, that's called private cloud, okay, because it's completely private to the particular company. Whereas just like the AWS offering, you are just using some offering by AWS or Google or anyone. Okay, that's called public cloud. That means your infrastructure is not in your in-house. You're just using one of these services, platform infrastructure as a or software as a service by the provider. Okay, that's called public cloud. But there might be some organizations where they may need a mixed one actually. Mixed in the sense there are some confidential data or confidential applications that they cannot move to public cloud. It's not only confidentiality, there are some regulations also actually. So that's one important point. Okay. Usually why some organizations will not be able to move to public cloud. There are a lot of regulations, just like our RBI will put some regulations if it's a financial application, or our telecom industry will put a regulation if it's a telecom application. Like that, they will put some regulations and they will put some rules around. Okay, if you are hosting this application on your premises, these are the things that you need to follow. Or if it is hosted outside, these are the things you need to follow. All these things. Based on that, they will look at their convenience and how you can make sure the regulators are happy with it. So that's the reason, that's another reason why you will choose a hybrid cloud. Hybrid cloud is nothing but some of your applications are on the public cloud, some of them are actually in the private cloud, and they can talk to each other as and when they need it. Okay. So based on their convenience and based on the situation, they will be able to choose hybrid cloud. Majority of the companies always follow hybrid cloud because there will be one or two application always need to be retained in their private network. Okay. That's the three different models, okay, of the cloud deployments. Okay, and that usually there are multiple strategies, okay, that the cloud deployment will follow. You can have a distributed cloud strategy where the cloud will be into multiple. You have multiple data centers where your cloud is hosted. You have multi-cloud strategy. That means it's not that you need to choose only AWS as your public cloud provider. You can have AWS, you can have Google, you can have Microsoft. All these cloud flavors can be available in your organization. Okay, so you, based on your application, based on that particular location or area, you will be able to choose what is right for you. Okay, so that's another thing actually you need to look at. And another most important thing we always need to look at is, okay, the security in the public cloud. Okay, this is the majority of the folks will have this concern always, right? Okay, so how are you going to maintain security? Okay, as in the public cloud. So one of the things that the public cloud offering companies are always doing is that there are two, three things they will by default will take care. One, as I mentioned, all the regulatory asks. Okay, let's say if your regulators are asking for log information, okay, for every application to retain it in a month or a week, whatever the tenure they want these logs to be retained. Because when there is a security incident, they obviously need to investigate and everything, right? So this is by default provided as a service by the public cloud folks, so that you don't need to worry too much about the regulators. All the regulator asks, they will keep a track and then they will give you an evidence that how this regulators can be satisfied. That's one thing. Similarly, your authentication and authorization. Let's say you wanted to log into an application, okay, and you definitely need to have a login mechanism, okay, Unless it's like a public open application, you don't need any login, it's just an information purpose, that's okay. But let's say your bank or a telecom company or any other important domain where you definitely need a login page, or you need to authorize the right people only to get into that application, right? So you'll have that login page, and all that authentication and authorization for your application can be maintained by the same LDAP services provided by this public cloud. So these are the additional services that they will provide actually, okay, as part of the platform, okay, or you can use your own LDAP, okay, so which will be able to take care of all these authentication authorization pieces. So that's another thing. And also not only just the authentication, but what about the overall application security, infrastructure security, and everything? So they will usually have all these scanners running on a regular basis. They'll give you that report, and any vulnerabilities that they call, let's say, uh, if you are active on recently, like you might have heard about the recent log4j vulnerability, okay, which has shaken the entire world, okay, and there are more now. There's one more, spring beans is going on right now. So the log4j vulnerability is something that has been in the ecosystem for some years, but recently got identified. There's a glitch in the log4j jar itself, okay. So let's say you have identified something like that, and you need to replace the log4j wherever it is actually. So log4j is like something very foundational and basis for every Java application. You can imagine every Java application in the world has to replace this log4j. Then you can imagine the scale, okay, how it can be done. So in fact, everybody did it. All the organizations have done it. Okay, so similar, these kind of things can be maintained by the same provider. Let's say if you have softwares as a service that you are providing, okay, which is using log4j as an underlying dependency, obviously it has to replace everything and send notifications to the consumers of the applications. So these are the things that will be provided by your cloud service provider. So to give that confidence and then assurance that, okay, and yes, and at the end of the day, no one can guarantee that none of their applications can be hacked or none of their platforms can be hacked, including AWS recently got hacked a couple of years back. Okay, the S3 database got hacked, right? Of course, it's an insider job. Somebody insider compromised the credentials and everything. That's why they were able to do it. Okay, so that's on the security part of it. Okay, so once we look into this, and one of the advantages, I think we did not talk about the fundamental thing. Okay, why cloud? Okay, so why companies are running behind public cloud nowadays? Okay, and why like what's so big about public cloud, right? Okay, one of the things that fundamentally, let's give an analogy, right? Okay, let's say you bought your computer, okay, your laptop or anything, you're going to spend like $1,000 or maybe a lakh, okay, on that. How much time you're going to use that computer in general? Okay, hardly like 4 or 5 hours in a day, okay, and you're spending that $1,000 or 1 lakh rupees for that computer. Like that, in the same conversation, now we have 12 people, you have 12 different computers, okay, and hardly we'll be using only 20% of that entire timing, okay, on an average, okay, of this computer, right? The remaining 80% for all these 12 computers is basically a waste of time or idle time for your computers. So that means you're not using all these computers with 100% utilization, right? Good. Let's think about this. All these 12 computers are connected to a network, okay, or maybe we are installing all these 12 computers, or maybe installing in a hardware, okay, with the same price, okay. Now we will be able to share, okay, this infrastructure, okay. All these 12 are connected and we can share whenever anyone can log in and then work on it and then go, okay. The same 12 computers can accommodate, okay, almost like another 20, 30 folks or maybe 50 folks, okay, unless until you have a duplicate. Basically, up to 12 people it can accommodate, not more than that. But if you look at the timing wise, one person work for 4 hours and the next slot is available, another person can come and work. Okay. So that's basically called a shared infrastructure. Okay. So usually companies, what they will do is they'll install a server. Okay. and then they will ask the individual terminals to connect this server, which is called a shared infrastructure. Okay, and but again, that is not 100% utilized. You have a shared infrastructure, but obviously, if you are working only 8 hours a day, hardly your company is using that infrastructure only 8 hours. Then what if the companies can come together and use a common infrastructure for all those companies, which is going to be even more effective. Okay, let's say you have three companies joined together. They decided, okay, this is our common infrastructure. We'll use 8 hours each by 24 by 7 clock. That is more effective utilization of the infrastructure. Okay, that's one way of actually doing this. And the public cloud basically is, okay, you forget about your infrastructure, building your infrastructure. There is infrastructure ready. You can just come, use, and pay only for the time that you have used the infrastructure. So out of 24 hours, if you are using it for only 4 hours, okay, pay for only 4 hours. Rest 20 hours you don't need to pay. So all this journey is because of the cost. So initially, when you're paying 1 lakh for your one computer, now in the pay as you go method, okay, when any public cloud, you will hardly paying, okay. Uh, let's say, for example, I have an AWS account, okay. I have an AWS account. I can spin any instance at any point of time, and if it is just my EC2 instance and I'm just using my own applications and all these things, hardly like I'm paying like 1,000 or 2,000 rupees per month. Okay, unless until I'm using additional Kubernetes, Docker, and all other services. So if it is 1,000 and 2,000 rupees versus your 1 lakh investment, which one you prefer? Okay, so obviously you're going to prefer the best service provided. Okay, and this is a journey. It's not like public cloud did not happen today. So initially we try to do the shared infrastructure thing, and we try to optimize the infrastructure using VMware. VMware is another actually best example before it comes to cloud. So basically, all this virtual machine concept came up, okay, where we wanted to optimize the infrastructure within the same company. There will be one virtual machine. It will spin off a virtual machine for you. Once you log off, the same virtual machine can be assigned to somebody else actually, the moment the other person logs in. So there's a shared infrastructure. You can actually share the entire thing. But the public cloud is to the next level, saying that you don't need to install anything. You don't need to spend too much time, energy, and money on this entire infrastructure maintenance. Okay, just we'll provide that as a service. You just log into our console and then work on it, and we can increase or decrease the infrastructure requirement based on your requirement actually. So let's say if you go to AWS, you can actually spin 50 instances on the fly, okay, which is like within seconds you'll be able to get 50 server instances. Okay, similarly, if you want to downgrade, you can downgrade that, and you will be charged accordingly. You will be charged only when you use that particular instance. So, which is highly optimized, okay, for any software company or individuals also, right? So, end of the day, the cloud journey is accelerated because of the infrastructure costs. Okay, your infrastructure cost has enormously increased if you go by the traditional method. Now, by pooling all of them, by effectively utilizing this entire infrastructure, by sharing this infrastructure between multiple companies, they were able to optimize the cost. All the cloud providers do the same thing actually. So they will put a shared infrastructure and then they will slice and dice between multiple companies and organizations, and they will charge it for you only for that slice. Okay, I'll take a pause. Any questions? Okay, so one quick thing before we wrap up. In order to learn AWS, you definitely need a AWS console account. Okay, and this is something basically the basics of AWS. You can just go through this, and also you need to log into AWS console. Okay, if you don't have an AWS account, please go and take an account. Of course, as long as you don't use any like additional services, that is basically price tag, you will be able to use it for free to some extent. Okay, but be careful. Don't keep your instances running when you are using it. your AWS, make sure you are actually taking them down before you log off. Otherwise, your the charging clock will continue. Okay. So what you need to do is you need to go and create an AWS account. Okay. You need to provide your credit card details or whatever. Okay, to get that account activated. Okay. Once you get this activated, okay, you will be able to create these EC2 instances and everything. Okay, so we'll get through that actually in the actual sessions. Okay, so these are all the services that are provided. Okay, look at this, all services. These are all the services that are provided by AWS. Okay, you can use these services straight away without any issue. Okay, so first thing, before you get into the classes, what you need to do is just create this AWS account for yourself, and then you can practice with me when we talk about it. Okay. Any additional questions from anyone?
Yeah, I have a question. I'm Purna. So for this course, do we need to do any kind of prerequisites like a cloud practitioner or anything like that? Because I just want to make sure I didn't do the certification yet. I'm planning to do it. So are there any prerequisites required for this training?
No prerequisites, Purna, but these sessions are going to help you to clear that cloud practitioner, associate, or architect. Okay.
Oh, okay,
If not
okay,
architect, but at least cloud practitioner and associate for sure. So I think that's a good question that you have asked. And one more thing is you need to remember is August 29th is when your format is going to change for only cloud architect. Your associate and practitioner format will be still same for the certification. Okay. For cloud
mm-hmm.
architect, if somebody is planning for cloud architect, the format is going to change on August 29th. So there will be a new exam format and then set of questions will be different post 29th.
Okay. So first is cloud practitioner, and then it's associate,
Yeah,
and then it's
practitioner,
architect.
associate, and architect. Yeah,
Architect. Okay. Okay. And this training will help to do the
yeah. This
certification
training
for
will help
practitioner.
architecture and associate. Good. Sorry,
Okay.
practitioner and
Practitioner and
associate.
associate. Okay.
Architect, you need to go deep into some of the additional concepts. We'll touch base, but in the interest of time, I'll ask you to continue that. And exam wise, I will ask you to go through the exam pattern and format because it's little tricky. Because you need to remember the exact terminology what AWS has if you want to clear the AWS exam. It's not like the generic terminology. So you just need to make sure you go through some of those sessions and then apply for the architecture at least. Practitioner and associate, you can just get it through.
Oh, okay. Okay. So at the end of the training, we should be
Yeah,
good to do practitioner
yeah,
and associate. And
right.
do you give any kind of in between the classes, do you guide any kind of mock exams that will help us through the certification?
You can, yeah, rather than exams, I'll give some mock exercises actually.
Ah,
Okay,
okay.
basically,
Okay. That's
I'll
good.
ask you to create some instances or ask you to create some load balancing stuff or maybe add some additional services and all this stuff. Okay,
Okay.
but not as an exam, as you say.
Okay. It's like mock exercises. Okay.
Yeah, right.
Okay. I think I'm good. Thank you.
Okay. Anyone else? Any other questions?
Yeah, hi. So one similar question, I mean, a common question. How much coding is required for all these process?
Zero.
Zero. Even for the
Okay.
cloud
Yeah.
architecture one also?
Yeah, yeah. So usually it is zero. But see, you need to understand your application, your own application well. Okay. If you wanted to be an architect, okay, so usually either it's a cloud architect, a normal solution architect, okay, you need to understand each and every aspect of that application, right from your design, your architecture, your development practices, okay, and your underlying platform and infrastructure, okay. So you definitely need to have an understanding and knowledge. Let's say you are a developer that is becoming an architect. That will be easy for you. But you want to directly become an architect without understanding what the developer will go through, what are the various phases and all, it is going to be really tough. Okay. So, but if you, let's say you want to become an AWS certified person and you're going to work in the platform area. So usually you will have your Wintel folks or Linux administrator, Unix administrator in the traditional world, right? Now you will have your cloud, basically your, you can call, you don't call them as administrators, but let's say you have your cloud team, right? So those folks don't need to be a developer. You don't need to code anything, okay? But you need to understand each and every service this particular offering is going to give you, okay? And should be able to help to configure that service and run the service. That's it. You don't need to write. And nowadays you have a lot of this software as a service things. Okay, you don't need to develop any applications also. If you are using any software as a service offerings from AWS, it will be even easier. Did I answer your question?
Yeah, thank you.
Yeah, one thing actually here. So I'm 8 years experience candidate. I'm a developer from the Android side. So while switching to AWS, is a good path to select the thing or how the things your session?
So Munikuma, you said you're an Android developer. Is that right?
Yes, yeah.
Okay. Yeah. So Android also you can use that as a platform actually. So AWS provides Android services as well. Okay, so you can just use the same thing, okay, but only the platform is going to change. That's it. Okay, so your mobile platform, okay, you're actually going to, you can leverage the same thing AWS here. Okay, or let's say you wanted to move from a mobile applications to the regular development, okay, and you can actually switch to any of these Java based programmings or anything, and then the same infrastructure will be provided to you.
Okay. And while switching the career path, I mean, from the Android side to the AWS, so
Mhm.
what are the difficulties? I'm a developer, so I know understand easily these things. Even I'm like the coding, but while switching to, I mean, I'm just passionate in the AWS and DevOps, so I want to start my career like this. So what are the difficulties I can face, and what are the suggestions you can do? Give it to
Okay,
me.
so okay, one good thing is if you are already a developer, you already are aware of, okay, irrespective whether it is a mobile development or a regular application development, there are some fundamental things that we everybody will go through, right? Like your SDLC, entire SDLC. Obviously,
Yes,
you have developed a code, you have tested the code, and you have deployed that code in various testing platforms. And eventually, you're going to deploy in the production platform, right? Live platform.
yes,
This concept is not going to change. Only thing that's going to change is your code, okay, which is instead of your Android development, then now probably you will use Java or any other programming language. The second thing is the platform. So from a mobile platform, you're going to get to the normal regular application platform. That's the thing. So the concepts will be same. It's only the thing is like from one flavor to another flavor you're changing. So if you're already a regular developer, I don't think there's a huge shift for you. Okay. But this is going to enable you to work in any type of applications.
mhm, okay.
Okay. Yeah.
And okay. And what about this salary package? I mean, is it same or it will be less? I mean, while choosing a career path change here, it's easily for the developers if you can get some good amount. But what about
Yeah.
these things? I mean, if it
Yeah, the salary wise, okay. So if you look at the public cloud, AWS and everything, it is becoming a fundamental thing for any role nowadays. Okay, so because all the applications are moving to public cloud. Okay, let's say you are a tester, you are a developer, or you are a production support person, or even you are a security person. For all of them, the AWS fundamentals, AWS is becoming like a baseline, right? So everybody
yes,
has to have a knowledge of how the applications will work in this particular platform. That's the fundamental thing. Okay. Now, if you want to become a AWS solution architect, or you are actually investing more time and you get deep into this space, that has more value in the current market. Okay, that's one point, right? But comparatively, when you say there is a role, there is an AWS certified person or a AWS knowledgeable or working person versus non-cloud person who's working in the traditional infrastructure. Okay, then this person always will have an advantage. And the market is good, okay, for all the public cloud related roles. Okay, So like almost every role nowadays I'm seeing is majority they're asking for a public cloud. Okay, it's not just only AWS. Of course, AWS is taking the majority of the market. Not only AWS, but you have Azure, you have Google Cloud, and all this stuff also.
Yeah.
Okay, so
So
yeah, I don't know what's your current salary range or what is your expectation, but definitely the salary ranges are far better than the traditional roles.
traditional essence developer side, right?
What is it?
Developer side. I mean, say that developer CTC ranges.
No, developer will always have an edge. Okay, so let's say you're a Java and full stack developer. Nowadays, that's the word they're using, right? If you're a full stack developer, obviously you'll have always have an edge. But if you're a AWS solution architect or you are a cloud expert, you'll always have even far better remuneration sometimes. And it depends on the
Okay.
company. Let's say there's an organization who's starting their AWS journey now. They are ready to invest a lot on the initial seed talent. Okay. And if they're already on the journey, they already have a lot of folks in the organization who's into this, then they will not invest much. They'll just hire someone and then train them. Okay. So it depends on which organization you're joining also and where they are in the entire cloud journey path. Okay, so someone is very new, is ready to invest a lot. Someone is already a seasoned one, they can get the talent anyhow.
So one thing here, if I have 8 years, so while shifting, the relevant we can put it as something, let it be some 3 years, 4 years in general.
No, no, can you come again?
So while switching the domain here for the company,
Mhm.
so
Mhm.
among the 8 years, I have full development life cycle. So if one switch to DevOps or AWS and cloud, so we need to put some of the relevant experience for this, right?
Okay, so as part of your development journey itself, you might have already used the CI/CD pipeline. You might have used
Yeah,
this
I did it.
DevOps practices, right?
Yes.
Yeah, that's it. So that's good enough. In fact, it's a right path also. You started with your development, get on to DevOps, and then your platform side AWS. Okay, so that will be a good path. And maybe sometime later you can also explore some of these production practices or SRE practices, which is a good combination for DevOps.
Okay. So that's I'm just confusing here. That's it whether I
Yeah.
can choose this the change or not. Because I'm the team lead
You
here,
can
so
always choose change. If there are two ways, right? Okay, one, you can be a developer, a engineering lead, and a development practice always. Okay, but you always need to look at what is beyond development. Okay, so there is a concept called a T-shaped developer in the industry that's moving on, right? Where you need
hmm,
to have a depth in one area, which is of course your development area. You need to know the breadth also, which is your requirements, your product designs, and everything. On the other side, you need to know how your application is going to work in the platform and the production also. That's where your AWS, DevOps, everything will come into picture. Okay. So in the long term, let's say you have wanted to grow vertically, okay,
hmm,
and you want to become a tech partner or a CTO, something like that for a product, then
hmm,
you definitely need to know all these areas. Okay, you should be having a command in all these areas. So it's a good opportunity for you. Okay, you have done your part in SDLC development. Now look into the parallel other areas where you can actually learn.
yeah.
And someone who has completed a full cycle, right from, okay, you have worked for some time in requirements, worked some time in development, some time in testing, some time in production support, okay, and some time on the platform and infrastructure side. Those profiles will be in more demand because
Mhm,
they are someone like who knows end to end.
hmm. Okay. Nice. Yeah, that's it from my side, actually.
Okay, thank you. Any other questions from anyone? Okay, thanks everyone.
So one last question. So what will be the timings for these sessions, like Monday to Friday?
Yeah, so tomorrow anyhow it's August 15th, so we'll not have session. So Tuesday we'll start, okay,
Oh,
and
okay.
7:30 IST to 8:30 IST will be the standard. Today, okay, we are starting at actually 8 a.m. right? Okay, but the actual sessions will be from 7:30 to 8:30.
Oh, it's 7:30 to 8:30 IST.
Yeah.
Okay. So it's like a 1 hour session Monday to Friday, but tomorrow you're closed. Okay.
Yeah.
Sounds good. Thank you.
Okay, good. Okay, thanks everyone.